So I'm now going to demonstrate some of the automatic registration tools that we have for MRI histology alignment. First thing you have to do is, under the settings menu, select either histology slide to reference image registration or reference image to histology slide registration. I'm going to select the second option. And what you get is a visualization again of the metric image. So if I translate this histology slide, this similarity metric image updates with the current metric between this histology slide and the current slice of the MRI image. And we can choose to view the current metric value. So this is an actual number corresponding to the quality of alignment. As it gets smaller, registration improves. And we can change the metric that we're using. So for example, here is the mutual information metric between the two images. I'm going to turn off the live metric value display. And I'm going to just change the opacity of our slide to 0.7 so that you can see the MRI behind it, or maybe 0.5. Okay, so let's try our best to align this histology slide with the current MRI image using a rigid body transformation. There it goes. Let's see it try to align the image. That's the best it can do. You can increase the degrees of freedom using full affine. And you'll notice that the histology slide begins to stretch a little bit more to align itself with the MRI slice. You can also do the inverse transformation. You can register the reference image to the histology slide stack. This time I'm going to use a rigid body transformation. And now what you'll see is the reference MRI image move to align itself with the histology slide. I'm going to turn off the opacity setting, it's a little bit confusing. So let's just view the histology slide using edges and click Run. So now what's happening is the MRI is transforming itself to match itself to the histology slide. Not bad for initial registration. Again, these features are currently in development and we're working on better optimization algorithms. You can go back now and choose to align the histology slide to the reference image. This time, we're going to actually include an additional parameter called a stack shift parameter, which lets the histology slide move up and down within the stack using this Z translation parameter in order to match itself to the MRI image. Now you can see the histology slide not only moves within the plane, but moves out of plane to try to get an optimum match along the K direction to the MRI image. So let's save this project just to show how all these numbers are saved. I'll call it simple histology MRI.z. And let's go to that folder. So here it is, simple histology MRI.z. Double click it. Again, here's the slide stack consisting of only one slide. Here is the transformation applied to that slide. You'll notice that translation has 3 coordinates. I, J are horizontal, vertical, in plane. and K is out of plane. And we also have a two-dimensional in-plane affine transformation matrix within comments. Now the reference image, or images, appear under the Reference Images tab. In this case, we only have one image applied, one image loaded, which is shown here under the First Image tab. The first image is given a transformation matrix, an affine transformation matrix, which maps from image coordinates to world coordinates, and then within comments we also provide the inverse mapping from world coordinates to image coordinates. And view properties are saved here under this tab. So this is how the transformation is represented when saving your project to a file. You'll notice that in the file we have a 4x4 affine matrix, whereas in HistoloZee we have the individual transformation components: translation, rotation, stretch, and origin. So what actually happens is internally that 4x4 affine matrix is decomposed into its various transformation components. And this is just so that the user has a more intuitive notion of what that affine matrix is doing. So it's very intuitive to see the translation components actually change and the rotation components actually change versus seeing those 16 matrix elements change and not really knowing what each of them does. Shears are applied using the so-called stretch rotation degrees of freedom. So this is the rotation applied prior to applying stretching or scaling. Okay, next I'm going to show you an actual reconstruction project of this tissue sample so that we can put everything together and see how it all works in practice.